Algebra 1, Lesson 19, the Standard Form. Writing an equation in the standard form is a way of writing it in a specific, consistent format that allows for easy analysis and comparison with other equations. In general, the standard form of an equation is written in the form ax plus by equals c, where a, b, and c are constants, and x and y are variables. Let's break down what each of these components mean in more detail. 1. A and b are the coefficients of x and y, respectively. These values indicate the scale of the variables x and y in the equation. 2. C is a constant, which represents the solution or output of the equation. This means that when you plug in values for x and y that satisfy the equation, the output will always be equal to c. 3. X and y are the variables in the equation, which can take on any value as long as they satisfy the equation. So why is it useful to write equations in standard form? There are a few reasons. 1. Consistency. By writing equations in the same format, it's easier to compare and analyze them. You can quickly see how different equations are related to each other and identify patterns or similarities. 2. Easy plotting. When graphing equations, it's often helpful to write them in standard form first. This allows you to easily determine the intercepts, where the equation crosses the x and y axes, and plot the line. 3. Solving for variables. Some equations can be easier to solve for one variable if they're written in standard form. For example, if you want to solve for y in the equation ax plus by equals c, you can rearrange the equation to get y equals c minus ax over b. Let's look at some examples of equations written in standard form. Example 1. We have the equation 4x plus 6y equals 9. Find a, b, and c as it relates to the standard form of an equation. So, if we refer back to the standard form, we'll see that a equals 4, b equals 6, and c equals 9. Example 2. Using the previous example, 4x plus 6y equals 9. Find both the x-intercept and y-intercept. Let's get to it. One of the advantages of the standard form is that it is simple to find the x and y-intercepts and just plot them on a graph and draw a line through them. You didn't even need to do any extra steps to find the slope, assuming you have a ruler and can draw straight lines, because in math we can't have crooked slopes. At least I don't think so. So, to find the y-intercept, we can just get rid of the 4x since we needed to plug in 0 anyway, and just solve the equation 6y equals 9. Divide both sides by 6 and then doing some simplifying, we get a y-intercept of 3/2. To find the x-intercept, we get rid of the term with the y and solve for x. So 4x equals 9. We divide by 4 on both sides and we get an x-intercept of 9/4. Example 3. Which one of these graphs represents the equation 4x plus 6y equals 9? If you chose C, that is correct. As you can see, the two intercepts we found also serve as points on the line. So, if we need to graph a line or even just find the slope, using the standard form is one of the easiest ways to get there. Example 4. Write the linear equation, minus 4x minus 7y equals 2 in slope-intercept form. To make sure we do the correct algebraic manipulation, we need to remember how the slope-intercept form is set up. So, to get the standard form to the slope-intercept form, we need to solve for y in terms of x. First, we add 4x to both sides. Then we divide both sides by minus 7. After doing those steps, we get the equation in slope-intercept form. Y equals minus 4 over 7x minus 2 over 7. Example 5. Write the following linear equation. Y equals 1/2 x plus 8 in the standard form. Now, there are a couple of conventional rules that we need to go over before we start the conversion to the standard form. 1. It's conventional for a to be the positive integer. Fractions and decimals should be excluded. If a is negative, you can multiply both sides of the equation by -1 to make it positive. 2. B and C can be positive or negative integers, but like with a, they should not be fractions or decimals. With that said, we can start the conversion process by subtracting 1/2 x from both sides. Now we have -1/2 x plus y equals 8. Since this is not in the conventional standard form, we need to multiply both sides of the equation by -2 to both get rid of the fraction as a and make it positive. Doing that, we get the final answer. X minus 2y equals -16. Example 6. Write the linear equation 5/6 x minus 10y equals -11 in point-slope form. This conversion is a little bit more of a challenge because we need to find the slope. There are a couple of ways to go about doing that. 1. You could find the x and y intercepts and calculate the slope from those two coordinate points. 2. You could convert into the slope-intercept form to easily find out what m equals. It's all up to what works for you and helps you figure out the slope the fastest. In my opinion, the fastest way to get to the slope is to convert into slope-intercept form. So we subtract -5/6 x from both sides. Then we divide both sides by -10. I'll give you a second to remember how to work with fractions. To find the slope, we need to divide the coefficient -5/6 by -10, which means multiplying by its reciprocal, which is -1/10. Now we have -5/6 times -1/10. -5 times -1 is 5, and 6 times 10 is 60. Simplify and we find that our slope is 1/12. We aren't done yet though. We need to find the x1 and y1 coordinates. A quick way is to just use one of the x or y intercepts as a point. Or you could plug in any random value of x in the slope-intercept form and solve for y to get an xy point that way. Let's say x equals 6, plug that into the equation, and we get y equals 1/12 times 6 plus 11 over 10, which equals 1/2 plus 11 over 10, which equals 32 over 20, which simplifies to 8/5. So a point we could use is 6/8 over 5. Now let's finish our problem. A linear equation in point-slope form for the same line. 5/6 x minus 10y equals -11. Is y minus 8/5 equals 1/12 times x minus 6. So in the previous lessons, we went through the different forms we could write a linear equation in. In this lesson, we learned how to convert each form into one another, and learned that some forms of linear equations help us get to certain information quicker than others. Get some practice working with linear equations because, believe me, they aren't going anywhere. See you in the next lesson.